Hello everyone, my name is Victor Bryman from M&B Renewable Energy. As you may know, we are into sales and installation of solar systems. I welcome you all back to this channel. In today's class, we'll be discussing the concept of electrical power. Note, this whole training is all about solar system design and installation. But before then, we need to understand electrical basis. In our previous class, we talked about the main electrical parameters, the voltage, the current, and the resistance. So today we will be discussing electrical power. Electrical power. What is electrical power? Electrical power is the rate at which work is done in electrical circuits. So this is the power that does the job in your electric circuit. It is the power that is converted into non-electrical energy, like your heat energy. In the case of your pressing iron, your mechanical energy. In the case of what? Of your electric motor. So the power that is converted into non-electrical energy is what we call electrical power. Please note the difference between power and energy. So energy is just the aggregation of power. So we can liken power to the rate at which a distance is covered, which is called speed. While the distance covered can be likened to energy. Like if you have an electrical appliance that is rated, let's say 100 watts, that 100 watts is the power. But you use it for like a period of 4 hours. So by the time you multiply that 4 hours with your 100 watts, so you should be having 400 watt hour. That is already the energy. So that's why I say energy is the aggregation of power. So we are going to discuss the three main types of electrical power. Types of electrical power. Here we have one, real power. We have two, apparent power. Then we have three, reactive power. These are the three main types of electrical power. What is real power? Real power is the power that does the actual job in an electric circuit. The power that does the real job in what? In electric circuit is called real power. So the real power is measured. The SI unit is watt. SI unit of real power is watt, which is W for short. Please take note of this. So this is the main power. You know, the power that comes from your source, it is not everything that is usable. So the part that is usable, that does the job in your electric circuit, is what we call real power. Then the higher unit of this, if you multiply this by 1,000, then we talk of kilowatts. 1,000 watts is equal to 1 kilowatt. Then 1,000 kilowatt, that is 1 megawatt. So we know we have all this in the concept of solar system. Then we talk of apparent power. What is apparent power? This is the product of the root mean square voltage and current, V and I. So it is the power that comes from a source. It is not all the part that is usable. So we can liken this to a beer. So let's use this analogy. You know, in your beer, we have the real drink. Then we have the foamy part, the foam. So this real drink, which is the part that is consumable, is what we can liken to real energy. While the whole beer, which contains this real drink and the foamy part, we can liken it to what? Apparent power. So even in the concept of solar, we have equipment. Some are rated in a volt-amp, because the SI unit of apparent power is volt-amp, which is V for short. And 1,000 of this gives us what? kVA. So kVA, if we're talking about kVA, we're talking about what? Apparent power. If we're talking a kilowatt, we are talking about what? Real power. Please let's take note of these two units. You know, even your inverters, some are rated in apparent power, and some are rated in real power. So that takes us to the relationship between real power and what? Apparent power. We say real power is I times V times cos theta. So this cos theta here is what we call the power factor. So if your inverter is rated in kVA, you can get the real power that can be gotten out of that inverter. So definitely the power factor will be given. If the power factor given is 0.8, what you just need to do is to multiply the apparent value, the apparent power, multiplied by the power factor to get what? Real power. Because this part is the apparent power. Apparent power. To 0.8, let's say you have an inverter that is rated 5 kVA and the power factor on it is 0.8. So 0.8 multiplied by 5 kVA, it means the actual power that can be gotten out of that inverter is what? Is 4 kilowatts. That is that. Please take note of this. Then the third one is the reactive power. So this reactive power, we say it is an unseen power. It's an unseen power. It is the power that flows from the source. It flows from a source, from the power source, to components like inductors and capacitors. Let's say your transmission line, it flows to and fro, building up electric and magnetic field. Electric and magnetic field, it builds this up and also collapses this. So that's why they will tell you that reactive power does no useful job, but it is applicable in transformers and devices like electric motor. So that is what is needed to build the magnetic field around the windings. Although we are not talking about that. Anything we are discussing here, we are discussing it with regards to what? To solar system. So mathematically, apparent power S is equal to the square root of real power P, then apparent power Q. So in a circuit where the real power, the reactive power is equal to 0, it means the apparent power is equal to what? Is equal to real power. Don't forget, apparent power is measured in VAR. Sorry, reactive power is measured in Volt-Ampere Reactive. That is Volt-Ampere Reactive. That is the unit of apparent power. Now we now discuss the relationship between DC and AC circuits. So we have something like this. We have a DC circuit, then we have an AC circuit. In the AC circuit, we have the single phase, then we have the three phase. Then we are discussing it with reference to real power, then apparent power. In DC, there is nothing like apparent power. The apparent power there is equal to real power. Like DC, maybe like your battery, the power that is gotten from it is real power from your solar panels. So that is just the reason why you can never see your solar panel rated in volt ampere. You have a watt. You have 300 watt, 500 watt, 585, 605 watt, 700 watt, and what have you. So in the concept of DC, the apparent power is equal to 0. Then the real power is the volt times current. But in the AC, apparent power is volt times current, but the real power is volt times current cos theta. You know, if the phase angle between your voltage and current is 0, it means your real power is equal to apparent power. So that is what we have in the case of DC. Because the phase angle is 0, you know your cos 0 is equal to 1. So 1 times VI will still give you what? VI. So the concept of apparent power does not exist here because reactive power is equal to 0. And we agree that if reactive power is equal to 0, it means real power is equal to, apparent power is equal to real power. Then if we now talk of three phase, here we say 3 times V times I cos theta. Then here we have 3 times V times I. Please, this is in the case of phase voltage. Please, let's take note of this case of what? Phase voltage. So we are talking of a delta connected system, like in a three-phase system. So what we have here is √3 times the line current, line voltage times line current cos theta. Please let us not misquote this. So that is that. Please, you need to understand everything about this so that if you have your solar equipment and some are rated in kilovolt, kVA rather, kilovolts ampere. What you need to do is to convert it to the real power. Let it be in kilowatts, because your appliances, after your energy audit, you will multiply everything. Your appliances, most of them are rated in watts. So you have to get the real power. Anything you are designing, don't design. If you have 5 kVA, don't assume you can get 5 kilowatt out of it. It's not possible, except it is stated on the nameplate or on the sticker that the power factor is equal to 1. If it's a unit power factor, it means the apparent power is equal to the difference. You can always check your sticker before you do your calculation. The power factor will be stated. Even in your appliances, they will give you voltage, current. For you to convert to the real power, you have to check what the power factor is. Then you multiply by the power factor. So power factor can be 0.9, 0.95. Now we have improvement in power factors. So that is that about power. Now, in the previous class, I made mention of some questions about the part that does the actual job in your electric circuit, the part that charges your battery, the parameter. You understand? So this is what? The power that does all this. The power that charges your battery, the power that causes electrocution. Is the power, the product of current and voltage. The product of current and voltage. Now there's a question I will be dropping. I just want us to write down what we feel about this question. So you will show the mathematical expression. Although it's a very simple one, I will drop it to question. One is with recourse to Ohm's law, the one we discussed in our previous class. So I will drop the 2 questions here. Let me know what you think about this in the comment section. You might just be the lucky one. The first question is, at constant resistance, voltage, current is directly proportional to voltage. The second one, at constant power, voltage is directly proportional to current. Now, this is the question one. We say at constant resistance, current is directly proportional to voltage. If you feel this is correct, you drop it, you back it up with reason. It's not just to explain and just define it. You understand? You have to show the mathematical expression and give analogy. Then the second one is at constant power, voltage is directly proportional to current. Is this statement true? If this first one is true, say yes, it is true. Then you give your reason. This second statement, is it true? If this statement is true, you say yes, it is true. If it is not true, you say it is not true, then you drop your reason. So I would like you to discuss this with recourse to your solar system connection. Yes, definitely. If you change, even if you are connecting, basically we have 3 types of connection. Let's say you have a connection that has to do with series parallel. If you increase the voltage, does the current has to decrease to get the same power? If you decrease the current, or the voltage has to increase. So discuss this with regards to your solar connection. Though we are going to discuss the types of, basically 3 types of electrical connection. Thank you so much. Please don't forget to like, share, and above all, subscribe so that you will be notified of our subsequent video. Thank you and bye for now.